the whole spectrum. So, okay. How many of you are front-end people? How many of you are back-end people? Nice balance. How many of you consider yourself systems people? Cool. How many of you use Heroku? All right, so I've got a couple of topics. These are really high-level topics, and I'm going to ask if you're familiar with them, and then I'm going to ask if you want to talk about them. So so how many of you have heard of Docker? How many of you use Docker? How many of you are interested in Docker? Cool. How many of you have heard of HashiCorp? They make Vagrant and all this stuff. How about Terraform, one of their recent projects? Yeah, okay, that's to be expected, not as many. How many of you have worked with webhooks in some form before? Yeah, it's kind of not that. I mean, we'll talk about it later, maybe. How many of you heard of Hacker Dojo? That's, okay, it's surprising. Okay. I'll just let you, who wants, it sounds like we want to talk about Docker because that's what everybody's familiar with. Okay, this is a really big topic. So if I had a screen, which I guess I gave up on. Really? Yeah, AirPlay's really smart for these things. Well, when it works. Here in Austin, I moved to Austin a couple years ago. Really, actually, to get away. I grew up in the Bay Area, in the South Bay, and then Hacker Dojo's in Mountain View. Started working at some startups in San Francisco, but when I moved here, I was actually trying to get away from the tech scene, and I didn't think I was going to start a company here. I thought I was going to start a band, but I instead started a company. Part of it is Docker's fault. So I worked on Docker before, when it was a Skunkworks project at a company known as Docker now, previously .cloud. Yeah, the thing took off. So it was one piece of the puzzle of this kind of like, modern systems world. And when it started getting really popular, I started writing a bunch of projects. I worked on the first killer application for Docker called Dokku, which is why I asked about Heroku, because it was a mini Heroku. And it would be really cool if I could show some stuff on here, but it's still not working. So Dokku was the first killer app for Docker. I actually looked this up because I was curious. Docker is on GitHub the second most starred systems project on GitHub. The first one is Linux, although maybe I'm cheating because Homebrew was actually the highest. I don't really count Homebrew as systems just because it's platform specific and and it's mostly not used by systems people. But so Docker's pretty popular. It's gotten a lot of stars, and for a while Dokku had like 70% of the stars of Docker, because at some point no one knew what Docker was and didn't really understand it. But Dokku made a lot of sense because they knew what Heroku was, and it helped people start getting a conceptual model of what you can do with Docker. So So I also worked on a project called Flynn, which was sort of a platform, another Heroku-like system. And then there's a project called Deus. It's another Heroku-like system that's open source. But I ended up just building a lot of interesting open source software components around Docker ecosystem, like Logspout to do dynamic log routing, and doing Registrator that is used for dynamic service registration, to work with things like console stuff and etcd, and built tons of open source, and wrote some blog posts about service discovery. And all this is really trying to get to like this ideal world that is something that we could potentially talk about as sort of the what is the point of Docker. I think people get confused with the point of Docker, but I ended up starting a company here because a bunch of people started coming to me about consulting around Docker and doing service discovery. So anyway, Glider Labs is now, I didn't plan to start it, but it's a company here in Austin, and there's like 4 of us, just kind of, we call ourselves a systems R&D lab. We really just, all we do is do open source software and do really cool things and consulting services. And we're kind of anti-VC, but we're growing and all this stuff. We do a lot of cool stuff in Go and weird stuff. Anyway, we paid for the pizza, so enjoy that. And what else was I gonna say? Glider Labs. Oh, we're kind of hiring. So if you're interested in any of this stuff. So Docker, throw something out there. Talk about whatever you want.
DevOps, managing disparate development environment.
Do you use Docker?
I've just toyed with it in the last like 5 to 7 days. But I mean, that's basically the problem I want to solve, right? Is I've got a dev environment, I've got a staging environment, I've got a production environment, and I do different stuff on all of them. I come from like a very startup-y, small company place. And so, my solutions tend to be hacks at times. Mm-hmm. And so I guess I want to understand like sort of best-in-class DevOps and how the pros doing this stuff.
So that's kind of like a systems design topic discussion. Any other proposals? Yeah.
So I have a couple Heroku apps that I'd love to port over to Dokku and kind of run cheaper on DigitalOcean. So I was kind of curious what the process would look like to do that. Are there anything missing in Dokku that would need to be added in order to replicate full Heroku experience?
Okay, maybe we'll come back to that one. Thank you. Any other proposals? Yep.
Orchestration. I was just looking into Rancher or Mesosphere or Tetum. What would you recommend for orchestration?
Okay, thank you. Another topic?
It's sort of similar to that. Have you used Amazon's Elastic Container Services? How does that stack up to these other solutions?
Okay.
You don't plan to found like Hacker Dojo here in Austin?
The answer is no. Yes.
I think kind of expanding on what you were saying about ECS, you have kind of a preferred container deployment solution.
Okay, thank you. Next one.
What do you think about Rocket from AppC?
Cool. This is a good list. We can probably touch on all of them. Any more? No? Okay. So the Dokku thing was pretty specific. So for those to kind of answer your question and just like put this information out there, Dokku is a single host version of Heroku. It was originally written in 100 lines of Bash, but it's very pluggable. Most of the heavy lifting is done by Docker and some other clever things. One big piece of it was a Docker container that implements the Heroku build pack system. How many of you are familiar with the build pack system. So Heroku can build any type of app, whether it's Python, Ruby, Java. And the way they do this is when you do that get push to it, it'll actually go and look for certain files, or basically detect which app it is, and then it'll run basically a compile script that will set up whatever that environment is. Install that version of Python, install whatever dependencies from the requirements txt, all that stuff, and then set up like kind of the standard runnable application. And this was all done before Docker existed, but it was sort of like an existing standard. And so I made a container called BuildStep. It was actually probably one of the first open source Docker containers that would do the Heroku build pack process. So you can just like, point an app at it, or like pipe standard in a tar of an app, and then it would basically give you an image that a Docker image that you could run that was your app in a Heroku-like environment. It would emulate all the same packages that Heroku has and all this stuff. Which, by the way, is a pretty good, I wish more people would do this. How many of you use Circle CI or like a hosted CI service? So I love Circle CI, and we use it all the time. But it's one of those things, just like Travis CI, where anytime you want to modify the Travis YAML or the Circle YAML, you have to like push and create a build in order to test your thing. It's really annoying. It'd be really great if someone, and I would if I had time, just kind of made a little thing that would emulate that environment. And you can do this for all kinds of different services. Opportunities for open source projects with Docker if you're interested. Anyway, so BuildStep did this. A bunch of other projects started using this. Deus, like I said, Flynn used the version. I kind of rewrote it. And then a bunch of other platform as a services that have come out since that are based on Docker use this project to have Heroku-like compatibility. The latest incarnation of this is called Heroku-ish, which is a standalone Docker container you can use to run Heroku apps locally, as if it's basically run your app in Docker very easily, whether it's local or you can build a platform with it that's Heroku compatible. In terms of like your app that's running on Heroku, you should be able to just spin up. And I worked at DigitalOcean for a while, and actually the reason why I worked there was because they made a custom app image that has Dokku pre-installed, and you just spin one of those up and then start and just push your app to it. And there shouldn't be anything you have to do to actually get your app to work. But you can, if you run into problems, just go on IRC, the Dokku channel. They'll be really helpful. So anyway, that's Dokku. And the interesting thing about Dokku is I don't really do anything with it anymore because it was limited. It was specifically designed to not be a distributed system. And that's how it was able to be like 100 lines of bash. And you compare that to Deus or Flynn, which are projects that are trying to be like a full distributed system platform as a service, and they're between 40 and 50,000 lines of code, not including their dependencies. Whereas Dokku right now is less than 2,000 lines. It certainly exploded more over the 100 lines that it started in. But anyway, so the thing about Dokku is it's very simple. You can go in and hack on it and learn how it works and all this stuff, and it's really great. But it's all because it has nothing to do with distributed systems. So it's great for personal projects and stuff like this. But probably everybody in here who has like real business use cases, although there are plenty, I keep hearing people using Dokku to run sites and apps in production, which is crazy. But the real challenge is building something like open source Heroku. And so you might think, well, there are open source Herokus, Flynn, Deus, and probably some others. And the interesting thing is that that's not really what I want. When I started working on Docker, what I wanted were some component pieces that I could put together something like Heroku, a Heroku-like system. I don't want a black box of a Deus that you can just it has a really complicated install process and you have to have at minimum 3 servers just to try it out, and it's going to run Ceph and do all kinds of crazy stuff. And it's really this black box, and you have to understand how it specifically works. And it might not do things the way that you want. And a lot of what PaaS is a workflow, kind of a predefined delivery pipeline workflow on top of basically a distributed scheduling system. Like most of what Heroku is a distributed scheduler, and then they put a router in front of it, and then that's Heroku. So what I wanted, actually, after using Heroku so much for a lot of interesting reasons, and App Engine and .cloud and all these things, I would say like the biggest thing that Heroku could do to increase its value is actually make their HTTP router optional, because it really makes it kind of limited to web applications. Like, what if you want to run an SMTP service or any other non-HTTP service? Specifically, other services that might power other services, right? Other system software. So that's when I was working at Twilio, this was we had this, Twilio started way before there was any good like EC2 management software, and so they built all this custom stuff that was really cool to manage EC2 hosts, but it was a really, really clunky process where ultimately they were running one. They didn't even use Chef or Puppet or any kind of configure. It was a very like automation oriented, but it wasn't any. It didn't look like any kind of configuration management system. It was based on pre-baked AMIs and but it was a really slow process to deploy anything. And of course, when you want to, when you're setting up a new service, you have to spin up at least one host. And Twilio was highly service-oriented architecture, kind of microservices before their time or whatever, because there was over 200 different types of services when I left. And so that means you needed at least 200 servers to run because of the way the deployment pipeline worked, right? You'd only run one service on one server. And so it was a pain and limiting and slow, and we had a staging environment that we had to like stand up, and really only one person could use at a time. And there's any kind of local integration testing was limited to like that one app. You kind of have to like mock out everything else, and you didn't really get there's no way you could run the entire system on your laptop. So, part of that was VMs are really heavyweight, and Docker kind of helped solve this. But so what we kept saying is we want Heroku, we want an internal Heroku, and my friends at Heroku said, well, why don't you just use Heroku? And I said, well, we can't because of your stupid router, right? We're Twilio, we do SIP, we do voice connect, all these things that Heroku can't do, and it would be ridiculously expensive if you know Heroku's pricing model. So what we did was we started to go through process that I recommend for anybody dealing with a system that they really hate, is idealized redesign. So we went in a room, and it's not a plan to create a V2 of the entire system. It's to create an imaginary V2 of the system if you could throw away everything, if you started over. But it's only in terms of what do you want, right? So you're thinking about ideal properties. I want to be able to deploy a system like a service like this, and I want to be able to do so and so, and you just list all these requirements, and then from those requirements you come up with a design, and maybe this is actually something that you can build, but you don't build it, you iterate your current system towards it. So then you're not iterating in a random path trying to fix whatever problem you're running into at the time. So we came out of that, and we had a bunch of interesting things that we'd have to build, one of which was what we're calling like Heroku calls them dynos, a dyno manager primitive, something that would basically manage containers on a host And then I left Twilio, and I went on a break for a while, and I started doing freelancing, and I ran into Solomon at .cloud, and they were trying to figure out a project to work on together, because he's a very design-minded engineer, which I can relate to, and he was talking about their V2 container technology. They want to do open source. It's a skunkworks project called Docker, and some guy was prototyping it, but then he left, and I said, well, that's exactly what I want to build. So we worked together on Docker, and I had specific use cases in mind that I wanted. I was like, you guys better open source this, and we kind of created the whole development process to be open source. They hadn't done a big open source project before, and eventually they were like, yeah, this is really interesting. I think we're going to pivot the whole company to this. And I became open source user #1, and I was like, oh great, that part's finished. I can move on. But of course, like Docker wasn't even ready to be used in production for quite a while after that. There's all these other problems, right? Everybody who's been playing with Docker, like you look at Docker and you're like, well, how do I actually do what I want to do? What I want to build with Docker, like something like Heroku or some kind of, I want to be able to run my entire system on my laptop, and then run pretty much the same thing in production, or get all these environments that look exactly the same. And how do I ship, what is the new artifact, and what are you, managing releases and all this stuff. But a lot of lessons came from the design of platform as a service systems like Heroku and Deis and Flynn. So what we've been doing at Glider Labs has been kind of going from the bottom up. Is most of our clients don't want Deis. It's too complicated. It's too opinionated. But they want something like it, which was the whole point of what I want to do. And so we'll work with clients to basically put together existing pieces, including Docker, in a way that's roughly the same architecture as a platform service that gets them a very similar experience, but you're not using Deis. And then as we do that, we open source these components. It's actually a really cool process of like prototyping and spinning things out into standalone components. And this was when I worked on Flynn, was kind of the real challenge. Was we wanted to do two things, which was create an out-of-the-box experience that was perfect, right? And Heroku-like, or better than Heroku-like experience, or it is a toolkit where you can build your own, because it's all based out on components, which was my influence. And at some point, because of the nature of the project and where the money came from, we were able to start with that. But as soon as they started running into trouble and they had to raise money, that VC influence, pushed them to make a product, and they kind of threw all those idealisms of component-oriented, blah, blah, blah. And they're just like, let's make something that works and it sells, right? Which I'm sure you can all understand, right? Because that's, you work at startups and you all, need to do that, and whatever your livelihood depends on your work and all this stuff. But most of my work has been for my free time. Like Webhooks was just like, oh, this is really awesome. I need to tell people about this. And getting companies like Google and GitHub and all these others that I don't even know about that integrate webhooks. I really want this ideal world of a world where I can just put together some components and build whatever system I want. And so the way we do it is open source and clients and blah blah blah. So there's a bunch of problems. You touched on orchestration, and that's one of those problems. You probably heard about Swarm, and the thing about that is, how many of you are familiar with Mesos or Kubernetes? So that is the abstraction that we're going for. If you were to take Heroku and remove that router and to put a lower level API on it, that's you'd have a Kubernetes or you'd have a Mesos. The problem with those systems is they're incredibly complicated. Mesos is the only one that you can really use in that people trust to use in production, because Apple uses it and Twitter uses it and all this stuff. But it's ridiculous. It started as a Berkeley project, kind of an academic project, and then it was adopted by the Apache Foundation, all this stuff, and that's where software goes to die, right? So, you know, what I really want is it's a great abstraction. This idea of basically abstracting away your host, so you don't really think about physical or virtual boxes anymore. You just think about processes. I want to run this process on the cluster, and you know, you might have some idea of where it's going to run or some biases about that. But for the most part, it's going to figure out where to run it, and it will run it and make sure it's running. And you know, there's all these other things, like Mesos has these different frameworks like Kronos that will do like cron-like features and all this stuff. But that's a really good abstraction, and that's, again, basically what I want. And, you know, Mesos and you know, a lot of people talk about Google Borg, and how many of you read the Borg paper that came out recently? So a couple of, or just one, just you. Really good paper, but that's the system that Google has been made and used forever, and so they've had this internally for a really long time. And supposedly a lot of their lessons went into Kubernetes, which, by the way, I really hated when it first came out because of the fact that it was basically marketingware for Google Compute Engine. You know, it was really biased toward their network topology, and really was, you know, they didn't really care so much about making a good user experience, you know, because they can just have Google Compute spin up what you need. And they're also trying to like get cash in on the Docker wave. It was announced, I think, at the first DockerCon. So it was all part of, you know, a big kind of interesting PR thing. But Kubernetes, I think, is actually the closest to the ideal. So the thing is that we've gotten really far without a scheduler orchestrator. We've done some really low-tech stuff with our clients just because that is, because you don't need that complexity yet. Now, the value for, the actual value for complexity is not worth it at this point. And so we've been able to do a lot simpler systems, container, you know, scheduling orchestration systems that are a little bit closer to simpler systems like CoreOS, their Fleet system. Although we don't use Fleet because it turns out just having SSH and systemd on the host is pretty much the same thing, and is a little bit more predictable. And so that's kind of what we've been doing. But we're still waiting for that our ideal cluster manager. And in terms of ECS, that's really interesting, but it's nowhere near it doesn't really do anything. I don't know, how many of you have played with ECS? Like, it doesn't really do anything that you can't already just do, you know? Does that make sense? So there's a lot of interesting stuff that Amazon can do in the long term there, but by then, like, you're going to have like a better Kubernetes or whatever, or Kubernetes will be much simpler, etc. So I don't actually. A lot of our clients were talking about ECS, and we just said, yeah, we can, you know, look into it more. But from what we know now, it's really not worth it. And so what we give clients, they're perfectly happy with, and is, you know, lots more simpler and portable and all this stuff. So Swarm, Docker's project, was interesting to me just because it was kind of starting over, is like a new opportunity. It's like, it's a greenfield, right? And they did a couple of things that were really nice in terms of their, the way they do their scheduling strategy. But what they're trying to do is make it all work through the Docker API, which is going to be very limiting because at this level, the semantics are different. You basically want to be, you don't really want to be talking about containers or Docker containers specifically. You want to be talking about, long-running services or one-off tasks or, those kinds of things. And with Docker API, they're the same thing, and it's just convoluted. And so I don't think the API is right. So that's kind of interesting. What we've been looking at is which project do we piggyback on to make our own version of this with a better API. And just kind of, because it's a hard problem, distributed systems are hard, and so we'd rather leverage the knowledge that's encoded in Kubernetes or Swarm, which there's not a lot there, but so that's the state of container orchestration. Yeah.
Can you talk specifically about Rancher? I just started to look into that.
Yeah.
And you think that's a good kind of low-level solution? You have
Yeah.
just a couple of server boxes?
Yeah, we work with Rancher Labs. We have a lot of really cool clients, mostly sponsoring open source work, and their Rancher. I'm actually more excited about Rancher OS, even though we use Core OS with all our clients. But their Rancher system, their little kind of orchestration manager, seems to be pretty good at what it does for now. But the problem is it's probably the most successful of many projects that are trying to do something like this. And the problem is that they were all trying to, kind of rush to get something out there, to iterate, to sell. And what they're doing is creating a lot of baggage, right? Just having a user interface is going to slow down your project and your learning, because you're kind of like, oh, we gotta rethink how we think about our conceptual model for container or orchestration. Not only do you have to redesign your entire system, but you have an entire UI and that you have to redesign, just like doubles the amount of work. So there's like first to market in this area, like I'm a little concerned about, just because most of the time what you can do with them, you can do with an API. That's not the case with Rancher. Rancher does a lot more. There's more intelligence in it and all this stuff, and it has a nice UI. So I like it, but we're still, we don't put clients on it because it's not our ideal. So we work in ideal systems, which is a very weird thing to say for someone who wants to make money. Yeah.
Do you ever use Docker's restart strategies, or do you always use systemd or something else?
Well, I try to only have one kind of restart policy making decisions, because you start layering them and it becomes unpredictable. It makes sense in cases where you don't have a supervisor, for example, in Rancher OS. I think I'm trying to think of specific cases we use them. But
choose between them. Would you always choose to use whatever?
I would use the most outer one, so systemd. But I have really mixed feelings about systemd. How many of you are systemd fans? How many of you don't know what systemd is? Yeah, there's a war going on. There's a bunch of wars going on, but systemd is basically, how like Linux is just a kernel, right? And then you have, and it's really like people say it's GNU Linux, because it's all these GNU applications, that kind of work together. They're all separate, right? But they all kind of work together to make a working Linux system. And then systemd is kind of reinventing everything. And it's got a bunch of pieces, but it's all kind of under one umbrella and one kind of vision of the system. And so it's kind of an interesting, new spin on Linux systems, and a lot of people love it, and I kind of do, but at the same time I don't, because I think in a world where everything runs in containers, and I know that they're thinking about containers, I do want my container engine to be able to have restart policies and stuff like that, because I kind of do want it to be the init system. Like that's why I'm interested in Rancher OS, because unless there's a gradient, right? There's like what's going to work for 80% of the people. If you had a good, if Docker was a great init system and you run everything in containers, that's going to work for 80% of the people, because you're not going to run anything on the host system. Everything's going to be run in containers, which is the Core OS sort of vision, except they're more pragmatic and know that you do need to kind of get in on the host and do stuff there. Plus, they're systemd nuts over there too, so they really want systemd to kind of own everything. So it depends, but systemd, sure, because we use CoreOS.
On staging servers, like when I just don't care, I'll just use Docker's, just the auto restart thing.
Yeah, well, I mean, ideally, your staging environment looks exactly like production.
Not the host.
Yeah, it depends. We want it, and actually, we do. Ideally, the architect of a cluster is scalable, so you can kind of run the same thing on a local VM on one VM and be able to run your entire application, all the services there. But then if you want to do a staging environment, it's also CoreOS based and looks exactly like production. It's usually what we set up. Yeah, people get away with, you don't need those kinds of sort of perfections. Yeah.
Yeah, can you talk a little bit about your kind of evolution in terms of programming languages for system tools development? I see it gravitating towards Go, but there's a whole bunch of other languages.
Like Rust?
Rust.
What else?
Well, networking-wise, Erlang.
Yeah. I put, Erlang's interesting because it's like brilliant when you're working in that. If we could redo everything, it would just be actor system all the way down. In fact, how many of you, there's a distributed systems meetup. Anybody of you been to that here in Austin? It's really small, but actually the one time I went there, they were talking about the actor model. How many of you are familiar with the actor model? So it's like a core primitive in Erlang, and it's basically, and I didn't realize, like, I was when I started really doing distributed systems and getting into Erlang, I was working in Python, and I was using I'd gone from Twisted to G-Event because of the whole single threaded, evented everything before Node.js. Although G-Event, if any of you are not familiar, or Eventlet, is basically like Go, but it's in Python. You have lightweight threads and all this stuff. And to me, when I was like, oh, this is the actor model, I thought, oh, well, it's just a lightweight thread with an inbox with a queue attached to it, right? Because that's kind of what an actor is in Erlang, right? You've got an inbox, you just pull stuff off on a, but it turns out that computationally it's like much more fundamental. And what's interesting is that it'd be nice if like all of computing was kind of based on this actor model. And so it was a realization I didn't have until I went to that meetup. But anyway, obviously the problem with that is it's a completely different mindset. It's not just functional programming. You're dealing with, the actor model, and that's not how a lot of people want to think. And Erlang has this VM, right, which creates another very big layer of abstraction, which people working with the JVM, which many people do, are comfortable with. But it's not something that is, to me, an ideal thing. You want to be you're trying to remove layers of abstraction and complexity. So if you can be closer to what's actually going on, on the CPU, is just a little bit more ideal. So that's why Rust and Go are more interesting to me as systems languages than Erlang, despite all its greatness. The other problem with Erlang is you're never going to write everything in Erlang, right? And you're always going to have to deploy stuff that's not Erlang, so you can't really assume Erlang everywhere. Which is my problem with people just thinking about the languages and Node.js people like completely isolated in Node.js world, because there's not only they're like relearning all the lessons that all these other older languages. Go, by the way, is like way older than you think because it was based on Newsquik, which was done I don't know, in the 80s. And if you anyway, so Go has an incredible amount of wisdom in it, and if you're not familiar, a lot of Go came from Rob Pike, and he worked on not only Unix but Plan 9 and Bell Labs, and I love Bell Labs. But I like Go. I haven't really played with Rust. There's some interesting properties to it as a systems language, but Go actually, this is a feature that I really wanted in Go. How many of you use Go? A couple. Cool. More Go programmers. Who wants to learn Go? Yeah, good. Go has a new feature in 1.5. If you recall, if you stay up to date with that, they are re-implementing the Go compiler in Go. And one of the things that they kind of just like added in there, because they wrote a doc to spec out this feature called, or what they call execution modes. Anybody familiar with execution modes or this talk in Go land? So right now you can just compile Go programs, Go binaries that you run a program. And you can use C libraries from Go pretty nicely, but you can't make something that you can't write something in Go that that you could like use from another language. You can't write shared libraries in Go. You can't write shared libraries used by Go, right? That was all like it's all single static binary, which is great. And so I'm glad that they had that, but there's always, there's some cases where you might want dynamic libraries, you want to do a plugin system or something like that, which I'm all about. Or the thing that has been something I've been really, really chomping at the bit for, which is I want to write systems libraries in Go that can expose a C API that allow you to write bindings in every language for specifically the problem of RPC, which is a project that's sort of my ideal RPC system, which is necessary for any kind of distributed system. Now I can not have to rewrite it in C, and I can implement it in Go and just write bindings directly against a Go shared library written in Go, which is really awesome. So one of the first experiments with execution modes, which will be in 1.5, was somebody writing a Go library used from Rust. So this opens up a lot of options now. You can actually write maybe your library in Go, whatever makes sense, and then use that in Rust. I'd probably stick to Go, but that's all really cool. The thing is, everybody's using Go, and actually everything that we use in our stack, from all of HashiCorp stuff, Kubernetes, a lot of other little one-off things, Rancher OS, a lot of Core OS, mostly is written in Go. And that opens up a lot of very interesting opportunities down the line when we figure out how to piece all these things together, because at some point we can kind of collapse them down into one binary and use them all as libraries, because they're pretty much almost all set up to do that. Right? If you're piecing apart a bunch of different things from different languages. It just so happens that all systems people doing stuff in this neat space are all doing Go, and Docker's in Go and all this too. So if for no other reason, that's why I like Go, because all this other system software is written in Go. If you look at Rancher OS's source code, they're using a bunch of Core OS libraries. So that's cool.
How about the GC though? Like, how do you do a shared library Go has to bring along its garbage collector?
Yeah, I think so I haven't really been able to investigate as much. I hired somebody to look into that for me.
So piggybacking on, I guess, your question about setting up a DevOps environment, if you have a startup who can afford a couple of dedicated boxes, what are the tools that you would recommend for the whole DevOps cycle, including what to use now that would be simple enough for a caveman to use to orchestrate the containers?
So you don't have to worry about infrastructure provisioning like AWS. You have some boxes already?
So go, yes.
I mean, roughly what we do, we're working on something cool that wraps Terraform that does all the provisioning stuff, so that gets you to that point. And then after that, see, the interesting thing is that we've been kind of, the great thing about containers is it allows you to eliminate the entire virtualization layer if you really want to. When we're working on, so before Twilio, I worked at in Mountain View at NASA Ames, and that's where there was a team that was basically some friends of mine were trying to make NASA cool again because they all grew up loving NASA, and then they all, some of them started getting jobs there, and we're like, what is this dinosaur? Everybody's just like a, just all red tape and is just really depressing. And so they wanted to make NASA cool again, and they started doing weird stuff with like Second Life and all this. But then they were like, oh, well, let's and actually, I started working with them because I was prototyping do any of you remember the L-Cross mission? They were setting up a satellite to do search for Earth-like planets. And there was a competing mission called TESS that was very similar, except instead of looking at, it was very focused, like L-Cross, it was looking at very wide pictures. And they would, you can't send these high-res, huge photos back to Earth. So they would have to do the analysis on the satellite. And so they said, well, if we're going to do the analysis, that wouldn't it be cool if, like, citizen science, like, people could run code on the satellite in space, processing and doing whatever analysis they want. And so they thought that was a really cool and engaging way to get people excited about this mission, and and they could just make a web app. People goes through phases. People submit an idea, and it runs on a simulator, and then goes on the satellite. And so I helped prototype this, and I think we used App Engine or something. And but there's all these problems because nothing cloud at the time NASA could use, because it all has to be on government hardware. And so they're like, all right, let's just make our own. So we started, the team turned into this. We started playing with eucalyptus at first, and then ran into a brick road and rage, frustration with the eucalyptus, and then they rewrote it, and that became Nova, which was what was then combined with the Swift or whatever to create OpenStack. And I was hired to not work on that, which is why I left, because I wanted to build the app engine on top of that. It was really OpenStack because it was going to be infrastructure platform, and then a bunch of high-level Django apps, which was crazy. But so, man, I went on a tangent. What was it?
Two or three dedicated
Okay,
boxes.
yeah.
What would you do? What tools would you use to develop the entire DevOps roadshow?
So if we can make some assumptions, let's throw CoreOS on there. If you can't do that because you need to use RHEL or something, that's unfortunate. So CoreOS. The reason why I got into that, I just realized why I went down that tangent, was because there's a huge advantage to being able to dynamically spin up hosts. And part of it is because if you're into like the immutable infrastructure kind of thing, where it's like, you don't use Chef and you're not, not mutating the state on all these machines, you can just kind of like spin up new machines. You can't really do that if you have the boxes. So that's a really significant part of the question, not one that we have a ton of experience with. So on one hand, you could run virtualization on top of those and do what we do. Or, in a way, it's pretty traditional. Like we would say, what are you going to use those hosts for? Like, what are they good at? Are they all, homogeneous, or, is one like, optimized for disk? It's got a bunch of disk or whatever. There's all these problems that, are part of the orchestration scheduling problem. One of the biggest things is making a very clear distinction between stateful things and non-stateful things, because state is a special case, and it should always be treated special. And a lot of orchestration systems talk about, like, everybody wants stateful containers and all this stuff, and I don't think that that's really, what I want to see are containers. What I really want to see are containers that are designed like appliances. So they're not just like, a little system image and you reconfigure them by like creating new config files. But when you run it, it's as if you're running a little, hosted service, and you interact with it with an API. And the cool thing that you can do with appliances in the VM sense is that you can actually have them coordinate. So you could launch a couple of instances of MySQL and have them coordinate to a standard master-slave replicated system, and then be able to self-coordinate all this idealized things. But we're getting so close to that; it's really cool. And and then have the APIs so that your management system can kind of do whatever you really want them to do. So state's special. Figure out what's going to run your database. You still have to design your system, but if you're, let's say, so are we working with microservices?
Yeah, so say you have one box with the database server, and that would be stateful, right? And then you have the other box that would be the web apps.
Cool, yeah.
And so would you architect it that way, and then you just have containers?
Yeah, it almost looks like traditional, 3-tiered, whatever, special database system. The cool thing is you can run, and some people do this and think that it's a bad thing, but it can be a good thing, run one container on one host. And the benefits you get is you have it as a unit of software, like that database. The fact that you're only utilizing one machine and you're not throwing a bunch of other things on there, like who cares? So run CoreOS on all of them. Run the database in a container, like it's fine. Do a bind mount host and skip all the crazy file system stuff. Hopefully CoreOS will be using OverlayFS by then. So you've got your database server, and then the cool thing is now you can run, if you have a bunch of microservices on your app nodes, you can just run them on there. Like, it's pretty straightforward, especially with 3 servers. You can do it in the old-fashioned SSH way, which is what we do a lot of the time, because we have and then kind of Ansible. Like, Ansible is really just configuration management wrapping the SSH client, which is great because you don't have this like daemon, you have to run, and the server you have to manage. You just, but we don't use Ansible. You could use Ansible. In fact, it would be a really good case.
You have to do away with all the other stuff and just do a very simple YAML file?
Yeah. I mean, the thing is that your configuration, you don't need configuration management now. We do all our configuration management with Cloud Config when we boot up the machine, because it's so simple, because everything's just running in containers and is either, runtime configuration or, comes from source code, all these different places that your configuration can come from. But Ansible, just orchestrate containers, and your Ansible scripts will be very small. If you wanted to, you could use Puppet, but there wouldn't be any point to adding that complexity.
What about the router?
Huh?
What would you use as a router in that scenario? In her scenario, where there's a bunch of microservices.
You know what's cool about routers? They weren't always software. And the cool thing is that Docker has created a new demand for SDN, which I think is uncalled for, specifically for why it's created demand, but it's a good thing, so yay. When we have good SDN, whatever that is, if you've heard of Weave or some of the others, Socket Plane got bought by Docker. SDN is really cool. Not just the reason why Docker bought Socket Plane was initially because they needed to solve this problem of how does one container talk to another container, and we solved this with good service discovery. We didn't even need to do an SDN, which is what we recommend if you don't need SDN. SDN's really good use cases when you have your own hardware and you need to have that good decoupling of physical SDN though, when we get that really good, I think we'll probably see a lot less HA proxies and Nginx because you can do load balancing at the network level again and do really interesting things. But if we're talking about what, we'll still want to do, everybody's familiar with Nginx and HA proxy, and those are totally fine. There's also Vulkan D. I don't know what else. Do you have other ideas?
No, could you go more into SDN and figure out how just binds a bunch of IP addresses to...
It creates an overlay network so that in the case of Docker, Docker as it works now, when you start up a container, it gets its own little IP that's basically local, and so it's not addressable from another machine because it's these systems like Weave will basically replace that so that it gets its own IP that's actually addressable across the network, which lives independent of your physical or existing virtual network. So it gives you an overlay network that gives every container an IP that's addressable, which is kind of cool because you can do stuff like hook and do, kind of VPN-like functionality, so you can have your laptop exist on the same network, even though as production, because it's virtual, so you can talk to all the IPs over there. And there's a lot of other cool stuff that we do with SDN, like load balancing and all kinds of other interesting things, but we're not going to see for a while, but it's like a big part of the future. So until then, you would use, most of our clients we set them up with HA proxy or Nginx, depending on usually what they're more familiar with or what they specifically need. Does anybody use other alternatives like Nginx and HA proxy? Those are staples, right? Yeah?
Nice. Nginx.
Yeah, so,
That's great.
in fact, that's my metaphor for cluster managers is we don't have the Nginx of cluster managers. Apache HTTP, is an Apache project, it's big. Some people still like using it, which is fine. I guess there's certain cases where it still makes a lot of sense, but it's still like this kind of big project, and it's actually, at the end of the day, pretty simple. But we don't have the Nginx of cluster managers. We haven't learned what the essence of it is to do the simplest, most effective thing. So Nginx is great at that. Although it's like usually web specific, so if you want to do TCP balancing, most people do HA proxy, and then you have to deal with its weird like moment of interruption. Yeah, and then most of our clients are on AWS, so it's to solve a lot of problems because we actually tell them to use hosted data stores. Like it used to be something you couldn't really do, but now we do it all the time until you need to host your own data store. So use RDS, use whatever, as well as their load balancer. ELB is amazing, but it's EC2 specific. What else? How's time?
We've got the room for about 25 minutes still. So
cool. What else?
Can you tell us about Hacker Dojo?
Hacker Dojo?
Yeah.
That, yeah. Have you heard of SuperHappyDevHouse?
Yes.
Have you been to one?
Yes.
Where?
In Incubator.
So DevHouse, I call it DevHouse. Some people try and call it by its acronym, SHDH, and then most people call it SDHD, which is wrong. So anyway, DevHouse is basically where Hacker Dojo came from. Who else is interested in this story? There's a long version and a short version. Oh, who knows what Hacker Dojo is? So it's a hacker space. It's kind of like this, sort of, except less corporate. So I'll do the short version. DevHouse was, some people call it the mother of hackathons, because you've probably heard of hackathons all over the place, and Facebook has their famous internal hackathon. But back in the day, there weren't hackathons. Like the closest thing was like a Linux install fest, and this is 2006, I think, by the way. And I grew up going to LAN parties, and I really loved that atmosphere. But I'm a developer, and I really like talking about technology. So I had this idea to do this event, which we did at a small scale, and I wanted to do a bigger version. So I talked to a friend of mine, David Weekly, who started PE Works and some other interesting things that kind of loops back in the story later. But so he had a big house that he used to throw big parties at, and I was like, can we do this event where we just hang out on laptops and work on projects? And he didn't get it. Nobody really did anything like that. And he's like, pitch it to me. And I'm like, I thought I just did. Like, I told you what it is. And so finally he's like, okay, we'll try it. And then we did it, and because of our friend network, a lot of interesting people came that were pretty vocal bloggers, people like Chris Messina, inventor of the hashtag, or Scott Beal from Laughing Squid is a really popular blog and hosting service in San Francisco, Matt Mullenweg, creator of WordPress, a bunch of other interesting people, and they came and we hung out and we just hung out and hacked on stuff. And David Weekly, who's the host, he for like a hosted wiki, because all his friends were asking him to set up wikis, because that's, there's open source wikis, but no hosted services. And so it's like, I'll make a hosted wiki service. And then like, he made it that night, in one night. And like a few days later, it had like 1,000 users. And then a few days later, it had a ton of users. And turned into one of the largest wiki farms on the internet. And that's where it was originally PBWiki. And then it turned into PBWorks. And he left after that because it's too PBWorks. So then that became what the event was. But anyway, to him, he thought it was an event where you come and you make something. But to me, it was just something where you maybe you make something, maybe you socialize, maybe you learn something. It's more about just like exchanging information, hanging out, and getting excited with other people with similar interests in learning things. And you bring your laptops, so if you want, you can be quiet, and you can work on stuff, and you can show people. So it's just very open-ended. And it turned into one of the largest things like it. It basically doubled in size every 6 weeks when we gave it. And at one point it was like 400 people. And it was never for profit. It was a bunch of like my friends, and then we made new friends. Basically people who hung out till the end, we'd have help clean up, and then we'd do a postmortem, and they became part of the, if they felt like they would come back, they would be part of the crew or whatever. And so we did these, and apparently the story goes, somebody who went to those was having lunch with Mark Zuckerberg, and he was telling him all about SuperHappyDevHouse, and Mark was like, we should do that. And that's where the internal hackathon came from at Facebook, where all innovations such as the like button have come from. And so it got really big. We had to do we couldn't do them at houses. We did them at Microsoft sponsored. So when you get to a point like that where you bootstrap something valuable, all the you go to Google and there's such badasses. They're like, whatever, we don't. If we sponsor you, here's your little room. But like Microsoft, who's desperate to get the attention of this community, they treat you like kings. So Palantir, another one, a bunch of these companies in the Valley that had all these resources that really wanted to get in good with this crowd, just hosted. They would just run the events. We're like, this is how it goes. They've been doing enough, and then they just run them. But it was always non-commercial. So at some point they got too big for us to actually do because we never scaled the organization. But what we did do was, after the 25th one, we said, hey, wouldn't it be great if we did this 24/7? Little did we know. And so that was the pitch for Hacker Dojo. And hackerspaces had existed before then. There was NoiseBridge, there's plenty of other ones. There's even one here that I've never been to, that one of the original DevHouse people was involved in, Martin Bogos. Maybe you know him. Hacker Dojo started, and it was kind of a hackerspace, but it was also kind of a co-working space. But it was also, it was less, it was a different cultural vibe, because it didn't come from that anarchy hacker scene. It came from the DevHouse scene, where everybody's happy and builds startups, and we're friendly to commercial, ventures and stuff like this. And so Hacker Dojo it got very popular as well. I think it's the largest hackerspace in the country now. But it's always struggling to exist because it's nonprofit, and traditional nonprofit, money raising is grants, and it's a really long cycle, and it's difficult and all this stuff. Most of our money, we were like, well, we'll run this as a business, so it's self-sustaining, so membership fees keep it alive. But the rent's gonna jump up soon, and all this stuff, and so it's just been a struggle to survive. Again, at scale. So it's always scale causes problems. Like you think you want it to be big and popular, but it just causes problems. So anyway, that's Hacker Dojo. Questions about Hacker Dojo?
So how is it different from the other package spaces?
It feels. What hackerspace have you been to, or have you been to like Noisebridge or?
I actually only been to Hacker Dojo and like this place.
So if you, I wish I could show you pictures, but if hackerspaces evolved from hardware hackers, because in order to do hardware hacking, you need a place to like store your stuff. So people that were interested in it would get together to like rent a warehouse and like put all their stuff, all kinds of things, you know. And it's almost like a big warehouse of old crap that people are like hacking on and repurposing and doing all kinds of cool stuff with. But it also attracted all, you know, the like security-oriented, you know, hacker people and black hats and people that identify white hat and black hat and all that stuff. And the thing is, to us, you know, we grew up idolizing Wozniak and John Carmack, and you know, they weren't security-minded people, but they were hackers and the like, you know, hacker ethic or open source software sort of thing. So when we would say hackers are hacking, we were talking about just like working, you know, driven by curiosity and passion. And technology. So there's definitely, I was going to say, if you've been to Noisebridge, Hacker Dojo is somewhere in between Noisebridge and Capital Factory, if that makes sense. It feels kind of corporate, but still DIY, because it's still kind of a top-down organization, but because of that, it can scale a little bit better than most hacker spaces that are just too chaotic and too much drama, because they're all, you know, it's an interesting topic. Anyway, other Hacker Dojo questions? Or something entirely different? What's that?
Rocket?
Oh yeah, Rocket. I did write that down. Rocket's interesting. I like the CoreOS guys. And I like their approach. Really, Rocket is about app C. And people compare Rocket to Docker, but really it compares to an execution engine of Docker. Like you could write an execution engine for Docker that runs Rocket containers. Unfortunately, there's some bad blood between those two companies that I don't fully understand. Knowing both of them, I still don't understand. And you know, part of it's philosophical. Like Docker wants to own everything, and the CoreOS guys want Systemd to own everything, and you know, that sort of thing. So, some good stuff is going to come out of Rocket, like the AppC standard and all this stuff, and maybe eventually Docker will be forced to implement that and be compatible with that. But at the end of the day, it doesn't matter. Like, just use containerization. At the end of the day, it's just like this concept, right? And then around that, it's just tooling. So whether you use Docker or Rocket, like if you use Rocket, you just have to solve more problems. And you have enough problems to solve with Docker. So, you know, that's why we still use Docker. Like at the end of the day, who cares about this app C spec? Like it's great, but like it's not gonna have you ship more applications faster, you know? It's like a tiny implementation detail. That's good, we need it, but also whatever. Does that answer the question? Or do you have a specific question about it? We haven't worked with it too much just because of our time, limited time resources.
I'm just wondering if it's going to fragment the containerization space.
I think it, you know, I kind of compared it to, probably a better analogy is like the Node.js and IO.js thing. And there was almost a possibility of the AppC stuff getting merged into Docker. And And then Solomon said no. Solomon's really like, I love him, but he's like, Docker's success is its own worst enemy. But I think it's only going to do good things. Like it's like AppC itself is going to make it so that there's more interoperability. So you could make other things, other execution engines and other tools if you needed to. But I mean, most people aren't going to want to do that. You know what I mean? Like, why fragment things? It's a lot better to just build tooling around both. And it just so happens like, but I do think Rocket serves the same purpose as IOJS did to Node in a way. The same way that, what was it, MERB did to Rails. And in both those cases, they merged back together. So I don't know if that's gonna happen, but also at the same time, I don't care. People are like, oh, we have clients who were like, yeah, we're gonna use Docker. They came with us to use Docker. And then they're like, so what about Rocket? And so we're like, well, you know, we try and explain it, and then, you know, at the end of the day, if for some reason magically there's tons of infrastructure around Rocket, which someday maybe there will be, but maybe at that point it's Docker. I don't know. Just like you've designed your applications for containers, you just port them. Like, it's not that big of a deal. It's not like going from like, you know, one paradigm to another. It's just changing tools. It'll be a hassle. People will complain. But other questions? Yeah.
How do you handle security updates? Do you just build all your containers again every month?
Yeah, see, that one's rough. And this is why a lot of these other kind of container wisdoms, like smallest possible containers with the fewest possible layers, is really good. Like if you can get a container down to a single static binary, which is the thing that you run, like you don't even have to worry about updating the host system inside. But like the way we design containers is, which I don't know if this is obvious or not, but containers are not VMs. You don't run. You can in special cases, but in terms of like building good systems, you know, don't run an init system inside a container. Don't run like all this stuff. Don't treat it like a VM. Only treat it as much as a VM as you absolutely have to. So if you have minimal containers, there's like nothing to update in them except the binary or Alpine, which is, for a while we were using BusyBox, and we would create a BusyBox base image, and we built all our containers on that. Just because, you know, sometimes you do have to shell out and use bash, and sometimes you do have to have curl, and you do have to have these other things, right? So you have to install those. But a package manager is great, but BusyBox doesn't give you that. Oh wait, OPKG, but that's like made for routers. And so it had really terrible package repositories. So one day someone pointed to me at Alpine Linux, and it's a modern, you know, BusyBox-based Linux distribution. But its big thing is its package repositories. It has like latest versions of everything, and so you can easily install packages there. So security updates for us is just like, you know, updating the packages or binaries in them. So it's very simple. But there's always going to be cases where, for example, if you are doing Heroku apps in Docker and you're emulating that entire Heroku stack, you have tons of stuff in there, not just like your Python interpreter and all this stuff, but your base image, OpenSSL, right? And that is a pain. So it's sort of like if people are people are able to get closer to the ideal, the less of a problem it is. But for people that do have to deal with it, the best you can do is rebuild your containers. You know?
Just do it defensively, like take a time period.
Yeah, I mean, at that point, it's no different than, I mean, it's a little easier to be able to do updates at that point. Heroku is like, how do we solve this problem? And I just told them that, rebuild everything, but they're like, but we're at scale. You know, if it's just you and your applications, then it's really easy. But if Heroku was to do like a rolling update of their base images for everybody's containers at once, it would be ridiculous. So, but I still think that's what you have to do because there's no other way around it, you know, if you design containers that way. So.
Yeah, I mean, even if you're running Python, some update will come down the pipe that you need to rebuild.
Yeah, and so, you know, the thing is that builds in Docker land is sort of partial, right? So if you need to change, if you do have like a full base image, you don't have to rebuild and set that up. You just have to, it's already got it cached in theory, right? So it's just going to rebuild once, and every other time that you rebuild, it's not going to have to rebuild it again. So
that's a good follow. So
yeah,
using the Docker build file versus using a tool like you mentioned, Ansible, to actually build the Docker image.
Yeah.
Just because Ansible has a much richer set of, I guess, primitives and tools to build things.
What's richer than the shell? I mean, run lets you do anything. I mean, you could use, but okay, go on.
Well, I mean, simpler at least. You know, when you do something on the shell, it might be 3 or 4 shell commands together. And if you're using Ansible or something like that, you know, it's just like,
yeah. Well, I think
this package is this sort.
Yeah, I think that is adding more complexity, and it depends on what that gains you. You know, again, if you're able to do minimal containers, like even non-minimal containers, like your Docker file is not going to look that complicated. You're going to install some packages, you might change some files because it's relying on some file stuff, and then you install some binaries. So I don't know.
You don't know where it's most annoying or bad. Like, if you want to, you know, if you're grabbing something on GitHub and you want your SSH keys, you know.
Secrets are that's a specific problem. Is that what you mean?
Yeah.
Is that what you're getting into? Yeah. So the conventional standard is, you know, kind of borrowing from Heroku 12-factor stuff is you put secrets in the environment. So if you put secrets in the environment in Docker, though, it actually gets added to history. So you have unencrypted secrets available as metadata on your image. If you build the environment at build time, if you do it at runtime and you do Docker run, you do -e or e, you know, a file with the secrets, it's a little better. But now anybody with access to that Docker host can see any of the secrets. For most people, that's fine because you have like a closed, protected environment. You're not that big. But at some point, that is an issue. And so in that case, we're looking at things like using Vault and then encrypting them in the environment's encrypted, and then inside is a really simple unencryption technique that does not depend on, ideally you don't have dependencies on other random pieces of infrastructure from inside your container. Right? You only need to depend on like your data store or whatever specifically it needs to connect to. So it's like, give it some input, here's an encrypted password, it knows how to decrypt it, and so that way it's encrypted in any metadata or any of the, when you do Docker inspect, it's encrypted there. It's not a solved problem, but that's the direction I think things are going. It's more work though, setting that up. Vault, have you heard of Vault? HashiCorp's solution to secret management. Brand new, bleeding edge. Okay, so any other last questions, statements? Yeah?
Well, I was thinking a little different. I'm thinking about these larger open source programs that include the infrastructure and the platform for orchestrations. I'm thinking of things like Proto or Red Hat, JBoss with Fuse.
Yeah.
What's the role? Where do you see the role for that? You know, maybe for less tightly integrated applications, more federated systems where it's more focused on maybe enterprise service bus or API publications. I think there is a role for that. I'm wondering what you think.
The role is enterprise and legacy.
That is the role.
Yeah, and I mean you're always going to have those requirements and those things. And until we have like a good answer for them in the, we call it the new world, then they're just going to have to keep using older, larger systems that were designed to be sold to the enterprise. So that's kind of what I say. I'm very sort of like let enterprise and legacy like suffocate itself. All right, cool. Thank you for hanging out. Yeah. Go first.
Yeah, so we usually head over to Buffalo Billiards. So if there's other questions or just socializing, nothing formal or anything, but we're gonna head over there. I'll be over there. I know a couple of others are.
Even less formal than this.
Yes, even less formal than this. Do you want to head over, or can you? That's cool.
I'm an introvert, so I'm exhausted.
Okay, so I will head over there, and if you have other questions, we can talk. I'm clearly not the expert that Jeff is, but I've done a little bit of this stuff. Yeah, if you want to carry the conversation on, Buffalo Billiards down on 6th and Brazos here. I'll be headed down in just a couple minutes, but thank you guys for coming out tonight.
Thank you.